Welcome everyone for a lecture on relational data model concepts. In those concepts, the first one is schema. Yeah, the first one is schema. Schema is nothing but it is a description. We describe that one by writing R and open the parenthesis and A to AN, where A to AN are attributes. Example is customer is the name of the relation, and customer ID, customer name, address, phone number are the attributes. Of course, there will be a domain. Domain is nothing but a set of possible values or valid values. Okay, suppose if you take customer ID should be 6-digit numbers. There's nothing but all the possible 6-digit numbers is the domain for customer ID. So from the domain only, a value should be picked in order to place as data in that particular column. So schema, domain, and then tuple. Tuple is nothing but ordered set of values. It should be enclosed in less than and greater than. And generally there will be 4 tuple. 4 tuple means 4 attributes. We call that one as n tuple, where there will be n attributes. Now in this example, 4 attributes, 1, 2, 3, and 4 attributes. That's why 4 tuple. And whenever you take a value into that particular tuple, it is values, set of values. Tuple is a set of values. When you take a value, it should be from that particular domain. Okay. And when you take a relation is nothing but set of such tuples. Tuple is a name given for a row. Okay. Then domain is nothing but all the possible values. Okay. For suppose if you take a USA phone number, it has 10 digits and it has a format also. There will be data type or there will be format for that particular domain. Okay, yeah, the format is this one, 10 digits should be there, where D is a digit, and we have to use the parentheses like this for first 3 digits. After next 3 digits, you are supposed to give an icon. There is one format. But suppose this is the format for date, and you can use another format for date. There's nothing but domain is giving the range of values. From that range only, you are supposed to pick a value as data into your table. Okay, and a single domain can play different roles. Suppose if you take date, it can play a role in invoice date, another role payment date. There's nothing but there will be 2 attributes in the relation under the domain date. So all the possible dates are is the domain for date, and from those possible dates you have to use either under invoice date or under payment date. That is what domain means. Okay, then state of a relation state. There's nothing but we have seen a schema R of a comma a1 comma a2 comma a3 so on up to a. That is a schema, that is a description. But when we come to relation state, it holds data. And that data will be obtained like this. It is obtained from Cartesian product of all of the domains of its attributes. There is a Cartesian product. So if there are 3 attributes, we have to take the domain of the 3 attributes. We will get all the values. We have to perform Cartesian product. Cartesian product means, okay, for suppose let's see a small example. For suppose in the domain for A1 attribute, the domain is 0, the possible values are 0. For A2 attribute, the domain is A, B, C. There's nothing but possible values are 1. Now the Cartesian product between domain of A1 with the domain of A2 is nothing but 0, 1, 0 A, 0 B, and 0 C. 0 A, 0 B, 0 C. And again 1A, 1B, 1C, 1A, 1B, 1C. So this is the Cartesian product of domain of A1 and A2. Now within our relation, we get a subset of this set. This is a set. from the set, we will get few values as as tuples, That's what the concept. It is subset. Relation state is a subset of Cartesian product of domains of its attributes. Okay. Now, if you see formally that particular summary, there is a relation R with attributes A1 to AN, and small r is the state of the relation. Capital R. Capital R is name of the relation. Small r is state of the capital R relation. It is subset of a Cartesian product of domain A1, A2, A3, so on up to N, means what of all its attributes. Okay, and when you take a relation state, it consists of some set of tuples. Okay, each tuple is a collection of values. Okay, and those values should be obtained from that's corresponding domains, attributes domain, that corresponding attributes domain. So if you take V1 is a value under attribute A1. So you have to go for domain of A1. From the domain of A1, you have to get one value, and you have to put that one value as V1. That's what the concept. So relation state is a set of tuples, where set is a set of values, where a value is from domain of that corresponding attribute. Okay. Then, so that is what the Cartesian product, and that concept is explained in this slide. And then, okay, so table is referred as relation, column header is referred as attribute, and all the possible values, values in that in any column, in one column, mainly in one column is domain of that column, domain of that particular attribute. One column is will hold values under one attribute. So all column values, possible column values, is nothing but domain. Row is referred as tuple. Table definition is nothing but schema of relation. And when you populate the table with some data, then it is state of the relation. Okay. Then this is what one small example. Okay. This is one relation. In this, one column is giving information about one attribute, and the top of that particular column is column header. There's nothing but the attribute name, and each row is in tuple. It is a tuple. Each row is a tuple. Okay. So relation name, attributes, relation. Within the relation there will be attributes, and there will be tuples. Okay. Now characteristics, that nothing but there will be some ordering of tuples. We have to follow that order for all the tuples. Okay. And then of course values in the tuple should be in an ordered fashion. How the column headers are given, like that only we have to maintain. But another point is the order of tuples is I mean, no problem if you change the order of the tuples, but the values within the tuple, that order should be maintained as it is. Okay. And then characteristics of relation. So there will be values in a tuple. Okay. So if you take T, V1, V2, so on up to Vn are attributes, are values, and those values are corresponding to the attributes, and those values should be obtained from domain of that particular. DOM is refers to domain of that particular attribute AI, and if it is not coming, if it is if the value is not from the domain of AI, that's nothing but attribute I, then you can place null value. You can place null in the place of value. Okay, a value should be either from domain of AI, otherwise it can be null if null is allowed for that particular attribute. Okay, then the notation, how to represent the values, that can be represented by like this: T of AI, where T is tuple, AI is ith attribute, otherwise T dot AI you can use. Of course, there is a concept called subtuple also. And then relational integrity constraints. Okay, integrity constraints. What are constraints? Constraints are conditions. Constraints are rules which are to be applied on the. Otherwise, we can tell if all the constraints are satisfied, then only that database, otherwise that particular relation state is valid, otherwise it is not. So main three types of constraints are there. One is related to key, second one is related to entity integrity, and the third one is referential integrity. So we maintain constraints for referential integrity, we maintain constraints for equity integrity, and we maintain constraints for keys. Okay, and of course one more fourth one is domain constraint. Domain constraint simple, nothing is there. The value what we are taking into a column, into an attribute, should satisfy the domain, otherwise should be from the domain of that particular attribute, otherwise it should not be allowed. That is what domain constraint. Of course null can be allowed. Okay, I mean you can write null apart from the domain of that particular attribute if null is allowed for that attribute. If null is allowed for that attribute, then only you can put null other than domain of that particular attribute. And then when you start with these constraints, the first one is key constraint. The first one is key constraint. And here we have super key as well as key. Super key is nothing but set of attributes. And what is key? Minimal super key is the key. Means what? A key is from super key only. But in the key, if you remove any one of the attribute, then it should be. It should not be a super key. Such type of keys only is such type of attribute collection only we call as a key. Okay, key means if you remove one of the attribute, then it should lose its quality of super key. Such kind of set of attributes is referred as key. Okay, and example for those we have for suppose a car relation. In that car relation, we have attributes like this: state, register number, serial number, make, model, year, and all those things. Okay, and when you look at this relation car, there will be two keys. There can be two keys. First key is with the state and registration number, and the second key is with serial number. Those are the two possible keys. Okay, both are also super keys of these two. Again, can be considered as, because a key can become a super key. Okay, a key can become a super key, whereas a super key cannot become a key. Okay, those points are given out here. A key is a super key, but not vice versa. Okay, any set of attributes that includes a key is a super key. Okay, minimal super key is a key. That's nothing but the minimal set of attributes from the super key will form the key. Okay, so there's nothing but when you take when you remove serial number from this super key, it will not be a key. So the point here is it will not be a super key. Okay, so this can be super key, but this cannot be a key. Okay, right then. Now there can be several candidate keys, but one will be chosen as primary. Key. Okay, of course, primary key should be underlined. Okay, and when you refer car relation schema, car is one relation. It has a schema. That schema is car of state, registration number, serial number, make, model, and year. Okay, now serial number is the primary key because it is underlined. Okay, so we choose serial number as a primary key. There can be, see, you can use, there can be so many candidate keys, but only one will be used. One or very few will be used as primary key. Okay, so you can make use of registration number. You can make use of serial number also as keys. Those are the possible keys, candidate keys. But one will be used as a key, that is nothing but the primary key. Okay, so the main point for primary key is nothing but it should be used to uniquely identify each tuple. Means what? In a table, you have to differentiate every row with other row. Okay, this is related to student 1. This is related to student 2. Like that, you have to differentiate. This is a record or row related to Ramu, and another row they will show, and this is the record for Ramu. They say like that because there can be multiple students with same name. Now, who is that Ramu and who is this Ramu? There should be some unique identification. For that unique identification, names can be same, marks can be same, address can be same, surname can be same, everything can be same, but this primary key should not be same. By using this primary key only, we uniquely identify a row, or in if you talk formally, a tuple. Okay. So primary key is used to uniquely identify each tuple in a relation. Okay, so it is used for tuple identification. It is used for tuple identification. Okay, and also used to reference the tuple from another tuple. Okay, and what we have to do? General rule is choose the smallest combination of minimum candidate keys. Okay, minimum candidate keys, and of course it is not always applicable. It is sometimes subject. It is based upon the data or based upon the environment, mainly the data. Okay, based upon the data it will be. So try to make the primary key as smallest as possible. So in this example, okay, license number is underlined. So license number is a primary key. So relation is car. Within that car relation, attributes are license number, engine serial number, make, model, year, like that. So many are there: make, model, year. Okay, these are all attributes. Now, out of all these attributes, so many attributes, one is selected as primary key. Of course, when you look at, you can make use license number as well as engine serial number as primary key, but we used only one. So those two are candidate keys, license number and engine serial number. Those two are candidate keys. Out of those two candidate keys, one is used as PK. What is PK? Primary key. Okay. Now, okay, we have seen a relation schema. Now this is a relational database schema. Now this is relational database. Database is nothing but not only one relation. There will be so many relations like R1, R2, R3, so on up to R, and so many relations. For complete database, in a database, then not only one table, there can be multiple tables. So when you talk formally, in a database, there will be multiple relations. So relational database schema is a set S. This is the set. Okay. So that belong to the same database. That all the relations should belong to the same database. So it is a set S, R1 to Rn, where Rn to Rn belongs to the same database. Okay. So S is the name of the whole database schema, where R1 to Rn are the names of the individual relation schemas within the single database S. Within the single database S. Okay. If you see one small example, this is the example for database schema. This is the example for database schema. Which database? Company database. For company database, this is the schema. How we write the schema? We write the schema. We write every relation name. Okay, these are all relations. Employee, department locations, project, works on, and dependent. All these are relations. In these relations, in each relation, if when you look at this one small relation, this is the schema about employee relation. This is the schema about department relation. So it is a collection of schemas. Database schema is collection of relation schemas. In a relation schema, you are supposed to write name of the relation and attributes of the relation. Now, out of these attributes, few or one attribute, mainly one attribute is selected as primary attribute. From the possible candidate keys, one is used here, one here, one, but here number as well as location. Here only number. Here number and SSN. Here SSN and dependent. Okay. So those are all keys, right? And that is about database schema. Now the constraints. Now the constraints. Okay. Now the first one, entity integrity. Entity integrity. Okay. This is a constraint for integrity. Which one? Entity integrity. Okay. So the point here is cannot have null values. Which one? PK. The attributes which you have taken as PK, primary key of a relation schema, are, there is a primary key attribute, are attributes PK in a relation schema, are within the database schema as. Okay, now there should not be any null values under PK. That is what entity integrity. Okay, in any tuple of relation state R of relation schema capital. Okay, so that is a terminology you are supposed to use during examinations. You have to use this terminology. If you write simply primary key should not be null, it is not sufficient. You have to use this terminology. Primary key attributes PK of each relation schema R in S. R is relation schema, S is database schema, PK is primary key, cannot have null values in any tuple of relation state small r of the relation capital R. Okay, so why no null values? Individual tuple. That's why if you give null, there can be multiple rows with null. Then how do you identify those multiple tuples? Okay, that's why T of PK should be not equals to null for any tuple T in the relation state of relation schema R. Okay, now PK can have several attributes or one attribute. So null is not allowed in any of these attributes. Any of these attributes. If there are multiple attributes as PK in any of these attributes, null is not allowed. Null is not allowed. Okay, and other attributes of R may be constrained to disallow null, even though they are not members of primary key. That's nothing but there can be some other X attribute, but that X attribute should possess some value, should possess a value, but it will not be part of the primary key, but it should possess a value. Means what? Null are not allowed. It should be not null. It should be not null. There can be a possibility like that. There can be a possibility like that also. Okay, so that is what entity integrity. Okay, entity integrity is nothing but primary key attribute values should not be null, but you have to use the terminology. You have to use that complete terminology. Okay, while explaining in examinations. Then referential integrity. Referential integrity is nothing but, see, you can remember like this: referencing, referring. Who will refer? One table data has some reference with another table. There's nothing but one relation has a link between of data with another relation. That is what this referential. Now we have to maintain that integrity. That is what this constraint. This is a rule. That is nothing but. Now what we will do is, suppose let us take our student relation. Within the student relation, okay, there can be so many details. For suppose basic details of the student is present in this student relation. Okay, there will be so many attributes like name of the student, average of the student, grade of the student. Otherwise, let us see, name of the student, address of the student, gender of the student, father name of the student, like that, some gender details will be there. In order to identify every record, every tuple uniquely, what we will do, we will take one more attribute, say role, and we will make that one as primary. So a role is PK in student relation, in student relation. Now there is a need of one more table. Say marks. Marks is another table. Okay, and in this marks, okay, for suppose we need to maintain subject 1 marks, subject 2 marks, so on, like that, and at the end we have to calculate, we have to store the total marks, for suppose. Now we are writing marks, we will not write simply the marks, right? We have to tell whose marks are these. So for that we require role. So what is role? What is role? Role is primary key. Role is primary key in another relation. Role is primary key in another relation. Consider this one as R1, relation R1, and this one as relation R2. Okay, so now this is in this table, in the marks table, the role will be the foreign key. Role will be the foreign key in the sense it is an attribute of another table, and in that another table it is a primary key. Primary key of another table is used in the present table for some referencing purpose, for some identification purpose. For suppose here marks, whose marks, this particular roll number, student marks. Other details of the student are present in some other table. Okay, here in order to maintain these marks, we are maintaining role here. So this will become foreign key in marks relation, which is primary key in student relation. Now the thing is here roll number 1. Here also you are supposed to, means what, the roll numbers what you are taking in this marks table should be equal to the roll numbers which are present in the table. For suppose if I write a roll number X, that X is not there in student table, then it is violating that referential integrity constraint. Because X is not in student, then how can you take X as a roll number and marks? You cannot take that. So that is what the condition. So in referential integrity, what they will tell is you should not take a value in the role under role attribute in marks which is not present in student. Okay, now come to this slide explanation. Let us look into this. A constraint involving two relations. Referential integrity involves two relations. For suppose student relation, marks relation. Okay, of course, when you look at the previous constraints, those will involve only single relations for some point. Okay, use it to specify relationship among tuples. What is the relationship? Okay, the marks, the data what we are putting in marks table has a relationship with one tuple in student. That's nothing but, for suppose roll number 1. Okay, there is a relationship among tuples in two relations. Marks is one relation, student is another relation, and there is a relationship between those two relations. Okay, now the referencing relation and the referenced relation. Okay, one is referencing relation, another one is referenced relation. Okay, right. So here there will be a reference. That's why it is referential integrity. Okay, so you have to follow the condition here. If the user is not following the condition, then it will be an error. Okay, we have to maintain this constraint. Yeah. Now, let us look at these points. Tuples in referencing relation R1 have attributes Fk. Fk is nothing but foreign key. So R1 is nothing but say for suppose marks. R1 is marks. Okay, it has foreign key attributes that reference the primary key attributes PK of the reference relation R2 student. And what is the PK? PK is roll number. Okay, so marks has a roll number. The roll number is foreign key. Foreign key means that is a column, that is an attribute from another relation, and in that another relation that actually is a primary key. Actually is a primary key. Okay, so now the integrity constraint is this one. Okay, a tuple T1 in R1 is set to reference a tuple T2 in R2. We can refer, we can write something in marks, one roll number in marks, only when that roll number is present in student. That is what this statement. T1 is a tuple. T1 is a tuple. Okay, and foreign key. T1 of foreign key is nothing but this is the concept we discussed at the starting stages of this unit. That's nothing but how to refer one particular value. Okay, like this. T1 of that particular attribute. Attribute here is T1 of role should be equals to T2 of role. Okay, the value in T2 should appear in as T1 as a value. That is what referential integrity. There is a condition. You have to follow that condition. If you are not following the condition in DBMS, when you try to execute a query, it will show an error saying that referential integrity is not maintained. What happened? There's nothing but we have taken a value which is not a value in the student table. We are taking a roll number which is not as a foreign key value, which is not maintained as primary key value. That's what the point here. Okay, so I think you understood this concept. Okay, now the last point. A referential integrity constraint can be displayed in a relational database scheme as directed arc. One arrow. In a diagram, like an arrow, we can refer from, we can draw from relation R1 foreign key to relation R2. Okay, that one we will see in diagrammatic approach. Okay, now, so again that referential integrity or foreign key constraint. So what is this foreign key? That's what more elaborately explained here. The statement of constraint is like this: value in the foreign key, or value in the foreign key column or columns. It can key can be a combination of multiple attributes, right? So multiple columns. Okay, value in the foreign key column Fk of the referencing relation R1 can be, you are taking a value. You are taking a value under foreign key columns in referencing relation. For suppose in marks table, Now that value, okay, that value can be a value of existing primary key value of a corresponding primary key in the reference relation. So point simply, it should be a value from primary key attribute of that particular reference relation. Otherwise, null in the sense, again, sometimes, okay, if you look at this example, this role again can be part of primary key for marks. Role can be acted as again primary key for marks table. Role along with something else. Can be used as a primary key for marks. At that time, you cannot allow null. Okay, that's what this point. Okay, you can allow null, but when if it is not a primary key, you can allow null in foreign key attribute as a foreign key attribute only when that particular foreign key attribute is not used as primary key for that particular table. Okay, then 1 second, 1 minute. Okay. Right. So next concept, displaying a relational database schema and its constraints. How to display it? How to display it? By going through this example, we can understand those points only explained in the previous slide. Okay, so we write names of those attributes. Okay, and on top of those attributes, we will be writing the name of the relation. Okay, and primary key will be underlined. Okay, and like that, this is the database, entire database. Okay, so not only one relation, all the relations are specified here. These are all the relations. Okay, and on all the underlined ones are primary keys. Okay, and referential integrity constraints can be specified by an arc. By an arc. So in department, there is one foreign key. That foreign key is manager SSN. This the value in the manager SSN should be a value under SSN in employee. That's nothing but manager is also an employee, and that employee is, for suppose SSN is nothing but ID, for suppose. Okay, so manager of in every department there will be a manager, and you are supposed to write the ID of the manager here. Now, whatever you are writing as ID of the manager should be there in employee table, in employee relation under SSN. Then only it is following the referential integrity constraint, that rule, that condition. Otherwise, it is not followed. Okay. So, in while writing queries in DBMS, if you violate this, if you are trying to give a manager ID which is not an ID of any employee, then it will show an error. Okay, that's what this point. So those points are given in this previous slide. This is the previous slide. Okay, so each relation schema can be displayed as a row of attribute names. We have seen one row we have seen. Okay, so this is a row. Okay, each relation schema. The name of the relation is written above the attribute names. Okay, that is what the name above. Okay, and then primary key attribute will be underlined. So that is why P number is underlined. Okay, then foreign key is displayed by using a direct arc, that is nothing but arrow from the foreign key attributes to the reference table. Otherwise, directly to the particular primary key also you can put the arrow mark. Okay, so example is this. Right, now moving to the next one. So so that is what we discussed about domain constraint. We discussed about integrity, entity integrity constraint. We discussed about referential integrity constraint, as well as we discussed about key constraint. Key constraint means so there should not be allowed. Okay, so those are all the constraints. And the next point is populated database state. Okay, by seeing the example, you can understand. This is the populated. This is a state. At one particular time, if you look at the database, the populated database, populated in the sense when data is kept inside the database, then we consider that one as one state. One state. Okay. So how to refer that particular populated database state is this one. Okay. So in the previous schema, we just wrote the names of the attributes. Now under the names of the attributes, you are supposed to write the data, and everything will be same almost. Okay, and here, okay, now let us look at this SSN. There is an SSN, and in the department also there is MGR manager SSN. Okay, here is a value. That value is related to Franklin. So what does it mean? For research department, Franklin is the manager. Okay, and now 98765. Okay, Jennifer. Administration department, or administrative department, Jennifer is the manager. Okay, and for headquarters department, James is the manager. Okay, you cannot write a manager SSN which is not available in employee. Okay, that is what referential integrity. And another one is, for suppose when you take project number, when you take project number 1, 2, 3, 10, 20, 30, there is no repetition. Whereas when you take a department number here, there is a repetition 5, 5, 5. That in this manner you cannot give in P number, because P number is a primary key in project. That P number is used to identify each project uniquely. Okay. Sometimes primary key involves two attributes, D number and D location. Both should be used. Okay, because the single department can be located in different locations. Okay, so if you simply write the location, it is not sufficient. You have to write the department number. Okay, the combination should be unique. See here under D number 5, 5, 5, 3, 5, 7. Okay, but if you see the combination 5 Bel Air, 5 Sugarland, 5 Host, you have to identify this difference. When you take multiple primary keys in a single table, the combination of those values should be unique. Okay, and similarly, you can refer other relations and find out the concepts, whether those constraints are followed or not. Okay, that is what one small example. Okay, then we perform update operations on relations. Updation is nothing but change. There should be a change in the relation in terms of data. When you insert a tuple, there will be a change. When you delete the tuple, there will be a change. When you modify a tuple, there will be a change. Okay, there will be a change. Okay. Now the point here is, when you do this one, you have to maintain the integrity constraints. So it should not be violated. Integrity constraint should not be violated when you perform update operations. Okay, so a database management system, otherwise database management software should look at it, should maintain it. Okay, database management software should provide those rules. Okay, when the rule is applied, then when data is updated, that rule should not be violated. Okay, and several update operations may have to be grouped together. Okay, so not only one operation, there can be several update operations. All those can be grouped together. And when you go for a change, an update in one place, then it will make an update in another place. In one relation, if you do update, it will affect in another relation also. That's the important point. So update may propagate from one place to other place. So it causes other updates automatically. Okay, this may be necessary. To maintain integrity constraints. Again, in one relation, if you are removing one data, that data may affect some other table. For suppose you are removing one row from one table. Okay, and in that row there is a primary key. That primary key is used as foreign key in some other table. So that also will reflect. So we have to, when you are writing a query, you have to keep all these things in mind. Okay, then okay, so I think time up again. Okay, up to 11:40, right? Okay, fine, no problem. 10 more minutes, right? Then update operations on relations. In case of integrity violation, several actions can be taken. That's nothing but while creating the table, along with the name of the table, name of the column, data type of the column, we specify the constraint also. We specify the constraint. Now user will be entering the data. Otherwise, user will be updating the data. Okay. When the user is updating the data, okay, so he will violate the integrity constraints. Okay. In case of any such kind of violations, in case of such kind of violations, we can take some actions. We can take some actions. What are those? General operation is cancel the operation. Cancel it. You cannot perform that operation. You cannot perform that operation because it is not following the integrity constraint. It is not following the constraint. Okay. So that is what by using restrict or reject options, we can cancel the operation. And another one is perform the operation, but inform the user that there is a violation. It depends upon the database management system software. However they want, they can perform that operation. Okay, and then trigger additional updates. So the violation is corrected. So when there is a violation here, okay, then what we have to do? We have to execute some other statements in order to correct that particular violation. In order to correct that particular violation. So by using cascade as well as by using set. There's nothing but when you remove a primary key value, then in the foreign key place in the table in which that primary key is used as a foreign key, in that table, in that particular record, what we should place, we can place like that. Okay, and cascade one more operation. Okay, otherwise, when that particular violation occurs, user can specify a function, otherwise a routine. User can provide an operation which can be executed in order to correct that particular error. So all these things can be performed. There's nothing but cancel the operation or inform the about violation to the user, or take some other updates so that the violation can be corrected by using cascade and set null. Otherwise, user can provide a function and operation. That operation will be executed. That function, that routine will be executed in order to correct that particular error. Okay, so those are the things what we can do when there is a violation, integrity violation, because of update operations. Okay, so what are the possible violations in each operation? For suppose if you take insert, you are entering new data. There's nothing but insert. In insert, there can be domain constraint. There's nothing but the entered data is not from the domain. Key constraint, that is nothing but a user may give null. Otherwise, user may give some already existing tuple related value. For suppose roll number 1 is already given. Again, if you try to add a new record with roll number 1, it is a violation. Then the referential integrity, that's nothing but foreign key in the new tuple references a primary key that does not exist. That is a referential integrity. Means what we are entering data for roll number X. Roll number X is not present in the primary key. I mean that student table. Then it is a violation. Then entity integrity. There's nothing but primary key is null. Then it is entity integrity violation. I mean entity integrity constraint violation. Okay. Similarly for delete also there can be some violations. So generally, it will violate only referential integrity. It will violate only referential integrity. That's nothing but foreign primary key related stuff. That's nothing but if you remove the primary key related record, then what? Then foreign key related table will be affected. The record will be affected. Okay. So what to be done? So if the primary, so let us look at that. If the primary key value of the tuple being deleted, primary key, there's nothing but in the student table, we are removing one student record. Suppose roll number 5 record is removed. Okay, but that is referenced from other tuples in the database. For suppose in the marks, again roll number 5. In the marks, again roll number 5. So what to be done? Can be remedied by several actions like restrict, don't delete, cascade. Cascade means propagate the new primary key into the foreign key of the. You give another value for that particular record in the foreign key table. Okay. Otherwise, you give null in the place of foreign key table value. Okay. So that is what restrict, stop completely. Cascade means propagate a new primary key value. Set null means in the foreign key table, or suppose in marks table, and under that, if possible, if it is allowed, then you can place null over there. Okay, one of the above options must be specified in the database design. You have to specify this one during the design itself. If it is like this, what to be done? If it is like that, what to be done? Everything you have to specify. Okay. Now, possible violations for each operation. Now, update may violate domain constraint. This is about update. Previous one delete. Previous one is insert. First one, second one delete, and the third one is update. Update in the sense modifying. Insert means new one. Delete means deleting one complete record. Update means existing one only. Values will be changed. That is what update. Okay. So that can violate. If the value is changed, it may not be from the domain. Otherwise, it may violate not null. It's what it should be not null. Some value should be specified, but they are giving null. That is also a violation. Okay. Any other constraints may also be violated depending on the attribute being updated. Other constraints can also be violated for update. What are those? Updating the primary key, updating a foreign key, and updating an ordinary attribute. Okay. So, suppose in domain constraint, in referential integrity constraint. The point here is we have few constraints. There is a possibility of violating those constraints. So, during the design of that database, we have to specify what to be done when there is a violation in the constraint. Okay, and we discussed what are all possible violations for each and every kind of operation, basic operations like insert, delete, and update. These are the basic operations. Okay, majority, because in these operations only there will be violations of those constraints. Okay, so with this we completed the constraints concept. We completed relational model concepts as well as the constraints concepts. And next we have to start with relational algebra in my next lecture.